Okay, Algebra 2 with Lesson 5.3. Guys, just recently, you dealt with problems where you would multiply two binomials together, something like this, like maybe x plus 2 times x plus 5. You might remember we'd FOIL. X times x was x squared, x times 5, you'd get a plus 5. Then you distribute a 2 here, you'd get a plus 2x, and 2 times 5 would be a 10, and before too long, you would get your final answer just like this. What we're doing today is we're going to work backwards. We're going to say, what if you started here and you want to go backwards? You want to go back to two binomials to see what two expressions would multiply together to get you x squared plus 7x plus 10. At first, that probably seems very, very difficult. But we have a nice way to help you. This is called factoring. And, page 4 in our notes here, also going into page 5. First off, we're always going to, at least today, have a lead coefficient of 1, at least for almost every one of these problems. The trinomial, the three terms that you're going to see, we're going to have a 1 out in front there. And, very soon we're going to start making it a little more challenging, and you'll see other numbers. But to get us started, we're going to have this. And I just want to tell you that, as this will help you later on, ax squared plus bx plus c is usually what we have for a quadratic, and for all the beginning problems here, we're going to let a equal 1. But the number that we have for b, we're going to look for two numbers that will add to that. The number in the middle there, it's a big clue for us. We're looking for two numbers that should add to a 7. This last number here, the 12, is what we're going to multiply to. Now, you might remember in algebra, I think most of you made a little wheel. And you'd say, look, I'm looking for two numbers to multiply to a positive 12. At the same time, I'm looking for two numbers to add to a 7. And it's like a little puzzle. You're saying, look, I know two numbers should multiply to a 12. But at the same time, when I add those two numbers, I'm going to get a 7. Well, you begin to ask yourself, what are the factors of 12? How could we multiply to 12? And, I heard someone say 3 and 4. Great. Are there any other ways we could multiply to a 12? 2 and 6, I heard someone say. 1 and 12 would also work. You could always start with a 1. 1 times 12 is 12. Then say, hey, is 12 divisible by 2? Yes, it is. 12 divided by 2 is 6. And 12 is divisible by 3. So here are our candidates, so to speak. These are the ways you can multiply to a 12. But you also need for them to add to a 7. So what do you think we're going to have here? 3 and 4. So we're going to have a 3 here and a 4 here. That's going to do the trick. 3 times 4 is 12. 3 plus 4 is 7. How do we write this? Look, you're done. You could change the order, but you're looking for two parentheses where you're going to have x plus 3 and x plus 4. Again, you could have changed the order. This is the factored form. It's working backwards. If I would multiply it out, if I distribute it out, I would get x squared plus 7x plus 12. Are we doing okay with that? Let's move on to number 2. Now, for number 2, life is going to get a little bit trickier. And I think everybody can see why. All of a sudden, you're going to have negative signs. And that does impact your problem for sure. You could say, well, look, I'm going to have to multiply and I'll make my wheel a little bit lower here. I'm going to have to multiply to a positive 8. I'm going to have to add to a negative 6. And that's really what's going on here. So multiplying to an 8, we're going to have to find out how we can do that. 8. What numbers multiply to 8? We'd have what? 1 and 8, or 4 and 2, or 2 and 4. Notice what you can do again so you don't forget a possibility. You could always start with 1, because 1 times that number itself would work. Try a 2. See if you're divisible by 2. 8 divided by 2 is 4. And here you have it. Now, the thing is, multiplying to a positive 8, but adding to something negative. Do you think both of the numbers are going to be positive to do that? Think about it. Would a positive 2 and a positive 4, or a positive 1 and a positive 8 possibly add to something negative? No way. You're thinking, wow, I look at the 2 and the 4 and it's good. 2 plus 4 is 6, but if you made them both negative, negative 2 plus negative 4 would add up to negative 6. And guys, if you're ever needing confirmation, it's totally okay to use a calculator if you're second guessing yourself, if you're wondering how to get this to work out. Here you have a negative 2 and a negative 4. They add up to negative 6, but at the same time, they multiply to a positive 8. That's what we're seeing here. We found the right combination. So what do you think we're going to write for our official answer here? We're going to write y minus a 2, y minus a 4. Sometimes kids will say, oh, wow, Mr. Dobner, I wrote y minus 4 first. Would that be okay, do you think? Yeah. And even in Alex, you can change the order around it. It's all okay. All right, we doing okay? Yeah. All right, so hopefully you're saying, I kind of remember doing this because you did do it in Algebra 1 for sure. Look, if you ever have just a z there or an x, there's always a 1 understood to be there. And the number in the middle always will tell you what you need to add up to. The last number will tell you what you need to multiply to. So let's see what we've got here. I'm going to multiply to a negative 6. And I'm going to have to add to a positive 1. So here we go again. It's really like a little puzzle. You just have to say, wow, how many different ways can I multiply to 6? There aren't a lot of ways you can do that. What's one way? 6 and 1. Yeah, 1 and a 6. What else? 2 and 3. And notice I didn't even put in negative signs or anything just yet. You'd say, look, there aren't a lot of ways you can multiply to a 6. This is pretty much it. But this is where it gets tricky. Because usually kids will say, yeah, I remember this. This seems to be where I'm in some trouble. You're going to say, hey, if I'm adding things together, I know one of these for sure. One of the numbers I'm looking for has to be a negative. Because if I'm multiplying to a negative, I have to have one of them be a negative. And I'm adding to something positive. So what do you think's more likely, the 1 and the 6 or the 2 and the 3? What do you think? Probably the 2 and the 3. They're closer together, right? That's a huge hint. They're only one step apart, and that really helps you out. But you'd say, wait a minute, one of these numbers has to be a negative, the other has to be a positive. Yeah. The negative 3. Now, if you think it's the negative 3, which is possible, this is like guessing and checking, you could double check and say, is a 2 plus a negative 3 going to add up to what we want it to add up to? No. Why? Because the bigger number controls the sign. The bigger number controls the outcome. I'm ending with something positive. That means my bigger number better be the positive. Right? Think of it that way. That will really help you. If I'm adding to something positive at the end, I want to make sure that the bigger number is the positive. And you can double check. You can real quickly just go -2 plus a 3. That's going to be a 1. And -2 times 3 is going to get you -6. So that's the right check. That's really what you got. So from here, I'm going to write z minus a 2, and z, this was a positive 3, I'll go plus 3. Right? What are we checking? You can see that -2 times 3 was your -6. I multiplied to what I needed to. When I add them, I add up to the positive 1. Okay, yeah. All right, so from here, we're going to take a look at 4. As we're looking at number 4, we're adding right here to -6. We're multiplying to -16. So this might get to be a little bit trickier. The sign is just as important. I've got to multiply to something negative, and I have to add to something negative. So let's see if we can come up with all the different ways we can multiply to -16. I'm so sorry. How can we multiply to a 16? What are some of the pairings? 1 and 16, I want you to start with that. Somebody said 4 times 4, good. 2 and 8, 2 times 8. And guys, think about it this way. Okay, 16 divided by 1, that works. That's 1 and 16. 16 divided by 2 is an 8, so we know 2 times 8 is 16. 3 doesn't go in. 4 does. And you've got the 4 showing up. If you really think about it, this is it. But you're beginning to think, hey, how could I get 2 of these numbers to multiply to a -16, but at the same time add to a -6? Well, my goodness, this is going to be a little bit more thought-provoking. Do you think the 1 and the 16 is a possibility? No, the reason is a 1 and a 16, even if one of them were negative, you're not going to be able to get them to add to become a -6. Kids would say, look at the 4. Well, if one of them's a positive, one of them's a negative, and that's what has to happen if you're multiplying to a negative, that would add up to a 0. You're going to be looking right here with the 2 and the 8. But think about it. If I'm adding to a -6, what number controls the sign? The big number or the small number in the addition? The big number. That means the big number has to be negative. If you're adding to something negative, your big number has to be negative. So I'm going to get this to be a -8. The 2 is a positive. And guys, sometimes kids just want to guess and check, and that's okay too. You can go 2 plus -8, and you can see that's going to do it. 2 plus -8 is how you get to -6. 2 times -8 gets you -16. It's these two numbers here that make the combination work. Okay? So what's your final answer? Well, we don't have an X, we have a C. So it's C plus 2 and C minus 8. I do want to say this. If you ever were nervous and if you were worried about whether this was correct, you could multiply it out and confirm that it works.